Welcome to Tomorrow Unveiled, the deep dive that takes the overwhelming torrent of technological news, the dense research papers, and the global industrial shifts, and distills it into the vital few nuggets you absolutely need to know to be well-informed.
And this week, we are really looking at history in the making. The past 7 days feel like a genuine pivot point for the entire robotics industry. We've officially moved past the era of the flashy, choreographed video demo.
We really have. This is where the rise of the machines becomes less about a science fiction movie and entirely about, well, battle-scarred industrial reliability.
Exactly. The question isn't, can it do a backflip
And
anymore?
the question is, how long can it work without breaking down? How many scratches does it have on its forearm after a month on the factory floor?
And has a safety engineer actually signed off on it, so it can work next to you without being a danger? The whole focus, the bottlenecks, they've shifted completely.
From what used to be pure technical capability, right? Like, can it walk? Can it grasp an object?
Right. To now, it's all about the operational constraints. We're talking safety certification, we're talking regulatory scrutiny, liability frameworks, and the big one, production scale.
And our dedicated research team has just compiled an incredible stack of information this week. It shows this transition isn't just happening in one company or one country. It's happening everywhere.
It is. It's in the hardware, the geopolitics, and maybe most importantly, in the software and the actual brains driving these machines.
And that's our mission here on Tomorrow Unveiled. We're going to unpack three major interconnected areas for you. First, we'll get into the real-world reliability metrics and some of the emerging legal challenges that are really defining deployment in the West.
Then we'll zoom out and look at the powerful geopolitical intervention that's reshaping the Eastern robotics market, this whole race to scale up.
And finally, we'll dive into the really radical breakthroughs in the AI brains, specifically synthetic data and these new world models that are just fundamentally changing how robots learn.
It's a packed week.
Let's get into it. So let's start with that hard proof. The evidence that robots are really moving past the demo phase and, frankly, getting their hands dirty.
For years, we've been looking for a real metric, not a vanity metric, but something that proves industrial viability. And this week, I think we finally got it from Agility Robotics.
The 100,000 Tote milestone.
The 100,000 Tote milestone. And the significance of Agility's digit robot achieving this, it just can't be overstated. This is not a lab.
No, this is a live commercial operation, a GXO logistics facility. It's messy. It's real.
It's verifiable, repetitive, value-generating work. And that completely changes the conversation from, speculative what if to measurable return on investment.
We've heard companies for years brag about hours operated.
Right.
And that metric, it's almost meaningless, isn't it?
It is. 1,000 hours could mean the robot was just standing in a corner plugged in.
Right. Was it moving? Was it actually manipulating things? Who knows? Right. But moving 100,000 totes, that's different. That provides the first real, what our research team called actuarial proof.
That's the perfect term for it. It's actuarial proof that this robot's as-a-service model, or RaaS, is actually viable.
And for anyone unfamiliar, RaaS is where you pay for the work done, not for the robot itself. You're paying per tote moved.
Exactly. And for an enterprise to sign up for that, the system has to be stable. It has to be robust, predictable. This milestone suggests Digit has finally reached that level of industrial-grade stability.
The research also highlighted a specific problem Digit is solving. It's this concept called the island of automation.
Yes. And it's a huge problem in logistics.
So what does that actually mean?
Well, think of a modern warehouse. You've got these incredible pockets of efficiency. You have these little autonomous mobile robots, AMRs, just zipping around the floor with goods.
Okay.
And then you have conveyor belts sorting packages at, unbelievable speeds. But there's a disconnect between them.
A gap.
A gap. And historically, a human had to be that bridge. A person had to physically walk over, take a tote off the AMR, and then place it onto the conveyor belt.
So that manual step was the choke point. The whole system's speed was limited by how fast a person could do that one repetitive task.
Precisely. And Digit closes that loop. It becomes the bipedal bridge. It walks over, picks up the tote from the AMR, and places it on the conveyor. It creates a fully autonomous end-to-end workflow.
It's the flexible link that all that other fixed, hard automation just couldn't provide.
And that proves the whole hypothesis of general-purpose robotics. But, the work milestone is really only half the story here.
What's the other half?
The safety precedent. This might actually be the bigger news. Agility passed a nationally recognized test lab field inspection, an NRTL inspection.
And that's recognized by OSHA, the Occupational Safety and Health Administration.
Not directly, yes. And that NRTL certification, I mean, that's the golden ticket. That is what validates the robot, not as a prototype, but as a legitimate industrial tool.
It's the stamp of approval that says it's a repeatable product that complies with industrial safety standards. The research specifically mentioned ANSI, B11.0, and ISO 12100.
And ISO 12100 is like the bedrock of machine safety. It's all about risk assessment and safe design principles. What this certification means, practically, is that Agility has proven this machine can operate safely in a shared workspace with people.
It's been through this incredibly rigorous examination of all its systems, mechanical, electrical, everything.
Everything. And without that stamp, you simply cannot deploy a robot next to a human worker in a Western factory or warehouse. Full stop.
So this one milestone from Agility, it just raised the bar for every other company trying to get into this space.
It absolutely did. The age of move fast and break things is over for robotics. Now it's move carefully and get certified.
Okay, so if Agility gave us the good news on the certification front, then Figure AI, they gave us the gritty reality of what industrial deployment actually looks like.
Yes, they did. So they retired their F.02 fleet after an 11-month run at BMW's Spartanburg plant. And let's be clear, the numbers here are just phenomenal.
The research team noted 1,250 hours of runtime.
Over 90,000 parts manipulated.
And they contributed to the production of 30,000 actual cars, BMW X3s.
This is manufacturing history. This is not a demo. And what I really respect is the transparency from Figure. They released these images of the battle scars.
I saw those. The robots were scratched up, they were worn, they were dirty. They didn't try to polish them for a press release.
No, and that's what I love about it. It's this refreshing honesty. They even publicly said that the main failure point was the forearm.
Right, because of the complexity. All the cabling and motors and hydraulics crammed into a space the size of a human arm.
Exactly. We have this image of robots as these perfect, sterile machines, but Figure showing those scratches reminds us that real deployment is about dirt and friction and things breaking.
It's just like any other tool in the assembly line.
Right. It signals the industry has finally entered that necessary phase where robots work, then they break, then they get fixed, and then they work again. That's progress.
But this operational success is, well, it's kind of overshadowed by a huge legal challenge.
It is. The research team highlighted a whistleblower lawsuit filed against Figure, and the allegation is pretty stark.
That the robot is powerful enough to fracture a human skull.
Yeah.
Okay, let's unpack this because this is where the rubber meets the road. Industrial reality colliding with legal liability and safety standards. Why is this one allegation so potentially crippling for the entire industry?
Well, it hits at the very definition of a collaborative robot, or a cobot. You see, for decades, industrial robots have been incredibly powerful and fast, but they have to live in cages.
For safety.
Who's safety? A cobot, on the other hand, is defined by being inherently safe. It's engineered to limit its force or stop completely if it makes contact with a person. And there's a global standard that defines all of this.
That's iOS 15066, right?
That's the one. It sets very strict limits on the amount of force and pressure a robot can apply to different parts of the human body. A head strike is obviously the most serious.
And the whole point of a humanoid robot is that it doesn't need a cage. It's supposed to work shoulder to shoulder with people.
That's its entire value proposition. So if the F.02 robot, even at its theoretical maximum force, goes beyond those ISO limits, well, two things happen. First, you can't legally or safely deploy it uncaged.
And second, if you have to put the humanoid in a cage, it completely negates why you built it in the first place.
It's gone. Why spend billions on bipedal walking in dexterous hands if it has to live behind a fence like a cheap, dumb robotic arm from the 1980s.
So this single lawsuit, it dramatically raises the stakes for the hardware engineering across the entire sector.
It does. It forces everyone to focus on ultra-precise force-limiting actuators, lightweight materials. Safety is suddenly a commercial bottleneck, not just a technical one.
So we're seeing this theme of endurance and reliability pop up everywhere. Pivoting to the east, the research team noted another interesting data point.
Agibot's A2. Setting a Guinness World Record for the longest autonomous humanoid walk. It covered 106 kilometers over 3 days.
That's incredible. And that's a huge proof point for not just navigation, but also for, sophisticated power management. They were hot swapping batteries on the fly.
But the real operational story in the East, I think, comes from UBTech. They're combining that endurance with a direct state mandate.
The research team detailed these massive government contracts, including a really specific $37 million deal to deploy their Walker S2 robots near the China-Vietnam border.
And look at the tasks: logistics handling, crowd management, and perimeter patrol. This moves humanoids out of the factory and into the realm of national security.
Which requires a totally different, much higher level of reliability and uptime.
Absolutely. And there's one technical prerequisite that makes this possible: the Walker S2's autonomous battery swapping capability.
This is a perfect example of an operational need driving an engineering solution.
It is. If you're using a robot to monitor a 1,000-mile border 24/7, you can't have a soldier running out to plug it in every few hours when the battery gets low.
It's just not feasible.
So, autonomous battery swapping becomes essential. It allows for near-continuous uptime, and it completely changes the economics of that kind of deployment. It's a technical solution demanded by a geopolitical reality.
So this whole shift from just capability to proven reliability, from demos to documented safety and endurance, it's defining the entire industry now.
The hardware is getting there. Now the operations have to catch up with the real world.
And that operational reality, which is often defined by those gritty details like power cables and liability lawsuits, is exactly why we do what we do here on Tomorrow Unveiled.
And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could take a brief moment to leave us a rating and review for Tomorrow Unveiled. It really, truly helps us reach new listeners and continue these deep dives into the future.
Okay, so let's zoom out a bit. Let's look at the bigger picture, at these massive and, frankly, divergent industrial strategies playing out around the world.
It's a really fascinating contrast. In the East, you have this state-directed consolidation, an attempt to prevent a bubble. And in the West, it's much more capital-driven, aggressive, individual competition.
A fractured landscape.
Okay.
Let's start with China's bubble warning. This was really surprising.
It was. Given the amount of state support for technology in China, to see this rare and pretty stern warning from their top planning agency, the NDRC, that was a big deal.
The National Development and Reform Commission. And this isn't just like a memo. This signals a major policy pivot, right? The NDRC is their top macroeconomic planner. When they speak, industry listens.
And industry shifts. The research team noted that over 150 companies have recently jumped into the humanoid robotics space in China. And that kind of uncontrolled growth clearly worries the state.
Why? What's the specific concern?
It's rooted in industrial efficiency and their ability to compete on a global scale. Their stated goal is to prevent a glut of similar machines. They want to avoid something called economic involution, or NAIWAN.
NAIWAN. Okay, that's a critical term for understanding their policy. What does it mean in this context?
It essentially means internal burnout or self-cannibalization. It's what happens when you have so much intense internal competition that companies just end up copying each other and slashing prices to survive.
So it wastes capital and it stifles real innovation.
Precisely. The NDRC is worried that 150 companies all making similar robots will just drain the available investment pool, prevent any real R&D breakthroughs, and ultimately cripple China's ability to compete against a giant like Tesla or Figure AI.
So they want to concentrate their resources.
Yes. They want to create a few national champions like UBTech and Unitree that can become giants capable of global export dominance, not a field full of fragile startups stuck in a domestic price war.
This focus on consolidation really highlights the sheer scale that's going to be required to win in this market. And speaking of rivalry, this is also where we saw that verification gap kind of widen with the whole fake video controversy around UBTech.
Oh, that was something. The CEO of Figure AI publicly accused UBTech of faking a viral demo video.
The one with hundreds of Walker S2 robots marching in perfect sync.
That's the one. He cited inconsistencies in the lighting, reflections, motion signatures, suggesting the whole thing was CGI.
And UBTech's response was pretty defiant. They released more footage to try and counter the claims.
They did, but honestly, regardless of who's right or wrong here, the whole spat just underscores a fundamental problem in a geopolitically separated industry.
The verification gap.
Yes, it's incredibly difficult for analysts, for competitors, for any of us to actually verify claims about mass production or fleet control when you can't see it with your own eyes. It just fuels mistrust.
So while China's trying to sort of cull the herd from the top down, the West is being driven by this very different individual ambition, and it's dominated by the targets being set by Tesla.
And Elon Musk isn't just talking about scaling up production, he's talking about self-replication. He describes Optimus as a von Neumann probe.
That concept, The von Neumann probe. We should probably explain that. It sounds like pure science fiction, but it really does guide their whole manufacturing philosophy.
It does. A von Neumann probe, named after the mathematician John von Neumann, is a hypothetical machine that can replicate itself. It can build copies of itself from raw materials.
So in a robotics context, Musk is basically saying that eventually an Optimus robot will be able to build another Optimus robot.
Yes. It speaks to this philosophy of absolute vertical integration. The factory becomes the machine that builds the machine that then builds more of the machine.
And the production numbers he's throwing out there are just as wild as a concept. The pilot line in Fremont is targeting 1 million units a year.
And the dedicated facility at Giga Texas, which they're calling Cortex 2, is designed for an incredible 10 million units a year in the long run.
His view on society is equally radical. He's predicting AI and robotics will make work optional within 20 years.
He's framing Optimus as a complete labor replacement platform for all of society, not just a tool for his factories. And that vision is what's driving this massive capital investment and the incredible sense of urgency.
Okay, let me push back on that for a second. We just spent a lot of time talking about the Figure AI lawsuit, which questions whether these robots can even meet basic safety standards for working with humans.
The ISO 156.6 standard.
Right. So how can we take a prediction of work optional in 20 years seriously when right now the industry is struggling with the question of whether a robot can touch a person without breaking their bones?
That is a fantastic point, and it's the perfect contrast, isn't it? It's the grand abstract vision versus the messy, granular reality of industrial certification.
Musk's timeline seems to be driven by the speed of AI development, which is exponential.
Right. He's assuming the hardware and the regulation will just catch up. But the Figure lawsuit proves that the real world is full of friction. The regulatory process, the engineering validation. It's a fundamentally slower, more linear process than just iterating a neural network in a simulation.
That's a great distinction. The software grows exponentially, but the physical world is constrained by linear, regulated reality.
Exactly.
But it's not just Tesla. The financial markets are validating other players too. Unitree Robotics is reportedly getting ready for an IPO.
At a targeted valuation of $7 billion, which is massive.
So what makes Unitree a good bet in this environment?
Their financial health is the key. The research team noted they reported $140 million in revenue for 2024, but critically, that revenue is diversified.
They're not a pure-play humanoid company.
Not at all. They sell those really successful quadruped robots, the dog-like ones, the G2 and B2 series. That's their bread and butter.
And then they have their G1 humanoid, which is priced very aggressively at around $16,000, mostly for researchers and universities.
And that dual-track strategy is what insulates them from the very bubble risks that China's NDRC was warning about. The stable, predictable revenue from their quadruped business acts as a financial cushion.
So it allows them to invest in the much more volatile, high-risk humanoid market without betting the entire farm.
Diversification provides stability. It's helping them sidestep that new trap that could swallow up their less established competitors.
And we're seeing this same geopolitical fracture play out so clearly in the drone space this week, too.
Absolutely. With the looming U.S. ban on Chinese drone tech, this European drone maker, Orca, is making a huge move.
They're massively expanding their capacity
to 280,000 NDAA-compliant drones a year. They're explicitly positioning themselves as the secure alternative for government and enterprise customers.
This is a direct response to the trade war, right? This political need for supply chain sovereignty.
It is. All those government agencies and companies that can no longer legally use Chinese technology are creating this huge new demand for a secure, non-China supply chain. Security compliance is now a primary selling point.
If you're finding this insightful, please take a moment to like this video, subscribe to Tomorrow Unveiled, and consider hitting that new hype button to help us reach more viewers. And of course, be sure to turn on notifications so you never miss an update on the future.
So we've talked about the body and its reliability. We've talked about the wallet and the race to scale. Now let's talk about the brain.
The software breakthroughs that are just fundamentally changing the pace of how these robots learn.
This is where it gets really exciting. Historically, the single biggest bottleneck in training any kind of AI, but especially for robotics, has been the data famine.
It's just so hard to get good data.
It's prohibitively expensive, it's agonizingly slow to collect, and it's always full of errors or incomplete labels. And this is why companies like Tesla and Google had such a massive competitive advantage. They had this data moat.
Built on billions of dollars and years of real-world fleet data collection.
Right. And that moat, that multi-billion-dollar advantage, it may have just evaporated overnight.
Okay, let's unpack that. The research team highlighted a paper on something called Interdata A1. What is that?
It's a massive, high-fidelity synthetic dataset. It contains 630,000 simulated trajectories, which adds up to over 7,400 hours of robot action data.
All computer-generated.
All computer-generated. And here's the monumental, game-changing breakthrough from the research. A vision language action model, a VLA, trained entirely on this synthetic data.
Okay.
It matched the performance of models that were trained on the absolute state-of-the-art, most expensive real-world data. They proved they could effectively close the sim-to-real gap for general manipulation.
Wow. Let's think about the economic implication of that for a second. If synthetic data is now just as good as real data for these tasks, it means companies can essentially compute their way to intelligence.
Instead of having to physically collect it over decades. That's the key strategic shift.
And synthetic data has some other major advantages, doesn't it?
Oh, huge ones. You can generate perfect labels instantly. In a simulation, you know exactly where every object is in 3D space down to the millimeter. But more importantly,
You can simulate failure.
you can efficiently simulate millions of rare, catastrophic failure scenarios, the exact moments where a robot drops something or slips or misjudges a grasp. Training on those edge cases is what makes a robot truly robust.
And trying to collect that many failure examples in the real world would take, decades of very expensive accidents.
Right. So are you telling me now that a small startup with a ton of computing power and a really good simulation environment could potentially match the data advantage that took an incumbent a decade and billions of dollars to build?
Yes, that's exactly what this suggests. It fundamentally changes the entire playing field by democratizing access to high-quality training data.
And accelerating that is this other advance, NVIDIA 002, which incorporates a technology known as world model.
A world model. This sounds like it's straight out of science fiction. How does this imagination engine, as some call it, actually help a robot perform better?
Well, the model can literally imagine the future. It builds an internal representation of physics and consequence. So before it executes a physical action, it runs a quick simulation of the outcome internally.
It's generating future frames in its own mind.
Exactly. It's hallucinating things like, if I reach for that cup at this speed, will I knock it over? Or, if I shift this heavy part, will it unbalance me? It can predict failure and plan around it before it happens.
And the performance boost from that kind of foresight must be huge.
The research team found it boosted success rates in real-world experiments by 50%. And it achieved a nearly perfect 97.4% success rate on a really demanding simulation benchmark called Libero.
The ability to predict the physical consequences of an action. That seems like the single biggest leap needed to go from a clumsy robot to a truly useful one.
It's a massive step toward what we might call common sense.
And trying to pull this all together, making it accessible for everyone, is NVIDIA. They just released Isaac Jirout N1.
Which they're calling an open AI foundation model, designed specifically for humanoids. This is huge because it gives companies a standardized platform to build on so they don't all have to reinvent the wheel.
What's really fascinating to me is the design philosophy. The research team described it as a dual system architecture that's meant to mimic human cognition.
It is. It's based on the idea of the brain's fast-thinking System 1 and slow-thinking System 2.
So System 1 is the fast, reflexive stuff.
Exactly. For a robot, that's the instantaneous motor control. It's adjusting your balance a millisecond after you pick up a heavy tool. It's catching a falling part without having to think about it. It's automatic.
And System 2.
That's the slow, deliberate reasoning part. That's the planning engine that figures out how to optimize battery usage over an entire shift, or resequences a multi-step task to be more efficient. It's the hierarchical brain you need to solve complex hierarchical problems.
And this brain was trained on a phenomenal scale using that synthetic data breakthrough we were just talking about.
Billions of frames of data, both real and synthetic, all generated using NVIDIA's Omniverse simulation environment.
And this is where you can really see the whole industry coalescing. The research team noted that Omniverse now includes a new, much faster physics engine called Newton.
And it was co-developed in partnership with Google DeepMind and Disney Research. This isn't just one company's internal project anymore. This is an industry-wide effort to standardize the robot's operating system.
And a faster, more accurate simulation means developers can test, 10,000 different designs or millions of failure scenarios overnight.
It just radically accelerates the iteration cycle for the entire robotics world, both hardware and software.
So while the humanoids are grabbing all the headlines and the huge funding rounds, this AI integration is also causing these radical breakthroughs in more specialized robotics, right? This revolution is much broader than just bipedal machines.
Oh, absolutely. On the pure hardware front, look at what's happening at MIT. Researchers there achieved these just dramatic performance gains in biohybrid robotics.
Biohybrid, what does that mean?
They used hydrogel tendons but attached them to lab-grown muscle tissue inside synthetic robot grippers.
So they're taking inspiration from biology and getting these immediate massive technical benefits in hardware. What kind of gains are we talking about?
The results were exponential. The research team verified them. 30 times more force output, 3 times faster movement, and an 11-fold improvement in the power-to-weight ratio compared to a conventional synthetic actuator.
Wow, so that suggests a future where powerful, fast robots aren't made with heavier, louder motors, but with lighter, more efficient biomimic systems.
That's the idea. And moving into the medical field, the Surgical Robot Transformer Hierarchy System, or SRTH, just hit a huge milestone in automation.
It performed a fully autonomous gallbladder remover.
On soft tissue phantom models, yes. And it did it with a verified 100% accuracy.
That's astonishing. I mean, soft tissue surgery has to be so much more complex than, say, working on a rigid bone. The tissue moves, it deforms.
It breathes, bleeds, it's completely unpredictable. Achieving 100% accuracy here moves robotics toward what's called level 4 autonomy in surgery.
What does level 4 autonomy mean in an operating room?
It means the system is taking the lead. It's performing the complex minute-by-minute actions of the surgery itself. The human surgeon's role transitions from being the one controlling the instruments to being a supervisor.
Just a watchful eye, ready to step in only if there's a problem.
Exactly. And this kind of breakthrough, driven by these advanced vision and planning models, could just revolutionize access to high-quality surgery around the world by standardizing procedures.
But dexterity, right, that's still the hardest challenge for humanoids. The ability to manipulate objects with the same finesse as a human hand.
It is, and Sanctuary AI's Phoenix robot is tackling this head-on by integrating new high-resolution tactile sensors into its hands.
And that's enabling what's called true in-hand manipulation.
Right. Most robots, if they need to reorient an object, they have to put it down, change their grip, and then pick it up again.
2 steps.
2 steps. True in-hand manipulation is like, twirling a pen in your fingers or adjusting your grip on a wrench without ever letting go. It's essential for complex assembly tasks.
And this isn't just in the lab anymore. The research team detailed a company called Mimic Robotics,
A spin-off from ETH Zurich, and they are focused specifically on commercializing dexterous robot hands that are trained using imitation learning.
So they basically have a human perform a task, they capture that demonstration with cameras and sensors, and then they use that data to train the robot hands directly.
It's a way to bridge that huge gap between complex academic research on dexterity and the actual practical needs of a factory floor. It's just so much easier to show a robot how to do something complicated than to try and program every single variable.
But then you have the messy reality of the real world getting in the way, like the Amazon Prime Air drone crash in Texas.
Yes, in Waco. The drone was on its final descent, and it severed an internet cable.
And that highlights this key hurdle, this last-inch problem that we keep coming back to.
It's the same idea as the warehouse, but in the air. Drones are great at cruising at 400 feet, but that final descent phase puts them in conflict with all this stuff near the ground.
Thin, semi-transparent obstacles like power lines, internet cables, things that LiDAR and vision systems can still struggle with.
And because any kind of infrastructure damage is a huge concern for regulators, this incident is a big deal. The FAA is investigating, and the research suggests this is probably going to delay the crucial waivers they need for beyond visual line of sight, or BVLOS, operations.
The industry has to prove it can robustly solve this thin wire avoidance problem before they can really scale up.
Exactly. And you contrast that immediate regulatory problem with the strategic move from Orca, the European drone maker we mentioned earlier.
They're expanding to 280,000 NDAA-compliant drones a year.
And that move is purely geopolitical. They are capitalizing on that political fracture to become the secure, non-Chinese alternative, guaranteeing that supply chain for defense and critical infrastructure clients who are now legally barred from using a lot of Chinese tech.
And finally, let's look at agriculture, where we're seeing this incredible high RI adoption of technology like carbon robotics laser weeder.
This is such a great example of practical, non-sexy automation that has a massive and immediate economic impact.
It uses AI vision and CO2 lasers to identify and just vaporize weeds with incredible precision.
And the research team noted that a single one of these laser weeders can reliably replace a 20-person human hand-weeding crew.
That's a huge return on investment.
It is, and it fundamentally changes the farmer's job description. The farmer is no longer a physical laborer. They're a sophisticated robot fleet manager focused on uptime and optimization. It's a perfect example of robotics being driven by pure, favorable economics.
We love hearing your thoughts. Whether you're on YouTube or your favorite podcast app, leave a comment and let us know what you think about the geopolitical split and the growing importance of robotic safety standards.
So if we pull all of this together, if we synthesize all the data from the past 7 days, from agility certification to that intern data A1 paper, the central theme is just crystal clear.
The industry isn't primarily constrained by the AI bottleneck anymore. It's constrained by the application and operational bottleneck.
The algorithms are advancing at the speed of light, but physical reality moves slower. The companies that win in the next few years will be the ones who master regulatory approval, liability management, and scale manufacturing, not just the ones with the coolest demo video.
We've really established what the new constraints are. It's not about raw computing power anymore. It's about 4 core industrial realities.
Safety certification, which agility proved is so critical.
Liability, which the Figure lawsuit has thrown into sharp relief.
Production scale, driven by Tesla's ambition and China's consolidation.
And data efficiency, with synthetic data from things like intern data A1 just leveling the entire playing field.
And this shift, it has these profound implications for the future of human labor. You see this clear contrast between Elon Musk's very aggressive work-optional prediction
And the immediate messy reality of the labor shift that's happening right now today.
The immediate reality isn't the elimination of labor, it's transformation. Physical labor is being replaced by cognitive labor.
The rise of the machines is creating these new human-in-the-loop roles. We're seeing the birth of the robot shepherd.
I like that term.
The person who's responsible for handling exceptions, doing maintenance, software updates, managing the battery fleet, replacing the person who used to do the repetitive physical task.
That laser weeder in agriculture is the perfect illustration. It didn't get rid of the farmer's job. It changed the job from kneeling in the dirt to managing a high-tech asset from a tablet.
Labor isn't vanishing, it's being compressed and elevated.
Yes.
So as we close this deep dive on Tomorrow Unveiled, let's circle back to what might be the most ethically provocative development of the week.
The synthetic data breakthrough.
Right. If Interdata A1 really proves that synthetic data can train these models as effectively as real-world data, that's a huge leap for development speed and for safety testing. We can iterate endlessly on safety scenarios without risking any hardware.
But it raises a really important question for you, the listener. What are the ethical and legal implications of training safety-critical systems?
Like that SRTH surgical robot that autonomously removed a gallbladder, or UB-Tech's security robot patrolling a border.
What does it mean when those systems are trained primarily in a pristine, perfect, simulated environment?
When an intelligence is learning exponentially faster in a safe, simulated matrix, we have to ask, do our rigorous human-centric safety engineering and liability frameworks, like the one that Figure AI is now facing, do they have any chance of keeping pace?
If the robot's brain never experienced true, random, messy failure in the real world during its training, can we really say it's safe when it's deployed?
It forces us to balance the incredible efficiency of simulation against the inevitable, messy unpredictability of reality. We really encourage you to explore the extensive source material provided by our dedicated research team for a deeper understanding of everything we discussed.
Thank you for joining us for this deep dive on Tomorrow Unveiled.
We'll see you next time as we continue to unveil the future.